Hey guys, Mr. B here, bringing you another amazing math video, as always. So in this video, I'm going to bring you through using the binomial theorem. So with the binomial theorem, I don't really have my students memorize too much with it. So I'm not going home and telling them, you got to memorize the first 20 rows of Pascal's triangle or anything like that. I sort of give them a little, basic understanding of it, and they can pretty much apply that in any situation. So if you don't know what the binomial theorem is, basically it's used to expand a binomial with some ungodly exponent on it, so n. So n can be any whole number, 1, 2, 3, 4, 5, 6, 7. So you've probably done this before, and you've probably used FOIL. So FOIL is how we expand two binomials. So you could also have something like, to the 2. So that's a binomial multiplied by itself. So when I have this n here, I might just have 3 multiplied by themselves. So obviously when you have 2, you can use FOIL, but when you have something like 3, you have to use FOIL with distribution, and then you have to use 4, it'd be FOIL twice, then distribution, and just a pain, right? So you can see why we need some kind of method to get around this, and that method is the binomial theorem. So the binomial theorem is useful for doing those, and I'm going to give you an example how we do it. We use combinations to do it. So so let me just give an example. So let's expand, say expand 2x minus 1 over x to the 4. So there's a couple things we got to recognize from this. So the first thing I always look at is that guy, and that is n is equal to 4. So that is the same n that we'll use in our combination formula, and that tells us that there are 5 terms in my my initial expanded binomial. So it might simplify after because we got some x's and things like that, we might cancel, but initially there are 5 terms. So that means when I write it, I'm going to have 5 separate things that I sort of need to work on. So it's actually really easy to get that initial first step. So all I need to do is recognize that this is my x, I'll put that in quotations, and this is my y in quotations. So really what I tell my students is you start with recognizing what your n value is. So my n value is 4. So I start with 4, choose 0. Okay, so 4, choose 0, that's going to be my initial coefficient. Then I have this guy, so 2 to the x. So that's like my x, and I don't know why I did this, but I did. So 2 to the x, all to the 4. So whatever your highest n value is, then you put it on your initial first guy. And then I have negative 1 over x, so it's important to include the negative, and this is initially 0. So any polynomial, you recognize that it goes from highest power to lowest power. So the x is the highest initially, and then this y is 0. So what happens to this is there's only really one thing happening. This guy's going up, this guy's going down, and this guy's going up. So these two guys always match, the 0 and the 0. So my next number is 4, choose 1, 2x to the 3. Whoa. Sorry guys, just had to check the baby monitor. I'm doubling as a parent tonight, all by myself. So that's why I'm making you math videos, because I'm bored out of my tree. So, and then this guy right here is 1, so these match. And really, if you want to know that number, really it just starts at the highest power and just drops 1 each time. So, but what you should notice is that these two numbers always add to 4. So whatever your n value is, it always adds to. And then it's 4, choose 2. And it's important to recognize this always starts at 0. 4, choose 2, 2x to the 2, negative 1 over x to the 0, plus, and then 4, choose 3, 2x, let me just slide this over a little bit, 2x to the 1. So I always have a tendency, I don't know where this mistake creeped in, But to start working back up with the x exponent, so try to avoid my mistake that somehow seeped into my head over the years. And lastly, for choose 4, 2x to the 0, negative 1 over x to the 4. Alright, so whew, all that written out, and you're saying now, that's the easy part, right? That is the easy part. So everything else after this is algebra. So we work out each one of these things, and there's a formula for a combination, of course. You know, n chooses r, and it's n factorial over n minus r factorial, and of course I'm not going to use that. There's no way I'm going to use that. So I have a Casio, and my students know that I am a huge Casio calculator fan, but I also have a TI. TIs are more complicated when it comes to this stuff. So all you got to do on this guy is, 4, choose 0, and it shoots back the answer. Of course that's 1. And then all I have to do is I have to put that number here. Isn't it lovely? Alright, so then I have to be careful with this next guy. So I have to go 2 to the 4, which is 16, and x to the 4, which is x to the 4. And then negative 1 over x to the 0 is just 1. Okay, so I might need to write that. Then 4, choose 1, so that's 4. And then 2 to the 3 is 8. X to the 3 is x to the 3. And then this guy is negative 1 over x plus, then I'll go 4, choose 2, so that's 6. And then I have 2 to the 2, which is 4, x squared. And then I have negative 1 over x to the 2, so that's negative 1 over x times negative 1 over x, which is 1 over x squared. So you can see here, initially, we're going to have some cancellation with some of this stuff. Then I have 4, choose 3, which is 4. And then 2x. And then this guy is going to remain negative, so it's going to be negative 1 over x to the 3 plus, and 4, choose 4. Oh, 4, choose 4, which is also 1. So what you should notice is look at the symmetry, right? 1, 4, 6, 4, 1. So that's important to recognize as well. And then I got this guy's 1, 2 to anything to the 0, and then this guy's going to be positive because it's a positive exponent, 1 over x to the 4. Just like that. So we can sort of start picking our way through this one and canceling some stuff. So the 1's don't really matter here. They're useless. So I just end up with 16x to the 4. Then I got 4 times 8, which is 32. And I had x to the 3 divided by, I can't forget about that negative, so that's actually negative 32. So we'll subtract 32 there. So x to the 3 divided by x, so that's x squared. Then I have 6 times 4, which is plus 24. I feel like I'm going to cough any second now. And then the x squared and the x squared, Ganzo. And then, excuse me, 4 times 2 is 8, last time I checked. Hopefully they haven't changed it on me. And then x divided by, and the negative comes from there, of course. X divided by x squared is x to the negative 2, or over x squared. And then last but not least, I have these 1's are useless, 1 over x to the 4, so that doesn't change at all. So, again, preference to write this, I don't really care. I'm just going to rewrite it because that looks messy to me. I think I'll put my coefficient at the end and leave my x's here like this. I won't put them as negative exponents, but you might want to check with your teacher to see what they like. So 16x to the 4 minus 32x squared minus 8 over x squared plus 1 over x to the 4 plus 24. Alright, there it is. Really easy to make a mistake with this guy, so I hope I didn't. Take that binomial to the power 4. And hopefully you can use this little method without having to rely on that big, long, old, crazy formula on the formula sheet. And thanks for watching. I'll see you guys in class. You can like my page or subscribe to my YouTube page. Thanks for watching, and I'll see you later.